Hi guys, this is Miss Carballo, and today we're going to talk about quadrilaterals and their characteristics and how they all relate to each other. So if we have, see, these are all different kinds of quadrilaterals. Quad meaning four, so they all have four sides. But some of them have special things about their sides or angles that sets them apart from the other ones. Like F and L over here have nothing special about their sides or their angles. There's nothing that's equal to each other. There's no parallel sides. But the rest of the shapes have something special about their sides or angles, and that's what we're going to talk about today. So this chart kind of helps us separate. This is one of the many charts I'm going to show you guys because some of these charts make more sense to others, like different ones. So this chart, this top part is the quadrilateral where nothing is special about the sides. So we're going to call the best name for that figure right there is a quadrilateral. It's also a type of polygon. So all quadrilaterals are a type of a polygon, which is a closed flat shape. And that's what all of these are, like triangles, pentagons, hexagons, right? So quadrilaterals is a type of polygon. But now we're going to look at sides and we're going to make them parallel. So this shape over here has one parallel side. See those arrows at the top and the bottom? And that shape is called a trapezoid. That's the best name for that shape. But it has all the characteristics needed to be a quadrilateral and a polygon. So you can also call them quadrilaterals and polygons. Best name being trapezoid. So these are one pair of parallel sides. These over here all have two pairs of parallel sides. So this shape is called a parallelogram, right? It's got a lot of parallel sides. The top and bottom are parallel and the two sides are parallel to each other. You can also call this a quadrilateral and a polygon because it has all the characteristics needed to be quadrilaterals and polygons. So let's make this parallelogram even more special and we can still have those two pairs of parallel sides, but now we have four 90-degree angles. So this is called, just like it was in kindergarten, a rectangle. And it still is called, the best name for this is a rectangle, but it has all the characteristics you need for a parallelogram and a quadrilateral and a polygon. So you can call it that as well. Then I'm going to take this parallelogram, and instead of making four 90-degree angles, I'm going to make all four sides equal or congruent. So this side, this side, this side, and this side are all equal to each other. Four congruent sides. So this is kind of like a square, but it doesn't have the four 90-degree angles. This is a rhombus. That's the best name for this. But we can also call it a parallelogram, a quadrilateral, and a polygon because it has all the things, the characteristics needed to be those figures as well. Okay, this guy in kindergarten was a square. The best name is still a square. It takes both of these characteristics, four 90-degree angles and four equal sides, and it makes a square. That's the best name for this. But it has all the characteristics needed to be a rectangle. And it has all the characteristics needed to be a rhombus and a parallelogram and a quadrilateral and a polygon. So we can call this square. It fits in all of those names, but the best name for it is a square. That's how we would identify this shape, just like you did in kindergarten. So that's how this whole map kind of relates to each other. These are all types of parallelograms, and all of these are underneath quadrilaterals, so they're all types of quadrilaterals. Now, these arrows on the sides are helpful too. So you remember those always, sometimes, never, true, false statements from elementary school that could have been so confusing. These arrows are going to help. So whenever we're talking about a shape from this side to this side going this way, it can never be that. A trapezoid can never be a parallelogram because a trapezoid needs one pair of parallel sides and parallelograms need two. So if I said, true or false, a parallelogram is never a trapezoid. That's true. It's never a trapezoid. You can't go this way. Okay, this arrow going up is always, all, and every. So if I start with a figure at the bottom and I relate it to a figure above it, then it's always that. A square is always a quadrilateral. Every square is a quadrilateral. It has 4 sides and it's a polygon. So every square is one, every single one. Every rectangle is a quadrilateral. Every rhombus is a quadrilateral. So when you're going down, up, it's always all parallelograms are quadrilaterals because I'm going up. I'm going from a figure that's down on this chart to up. So all of these are quadrilaterals. Okay, this one, if you haven't guessed yet, is going to be our sometimes or sum. So some quadrilaterals are trapezoids. They look like this. Some quadrilaterals are squares. They look like this. Oops, sorry. So when you're moving down, it's some. Some parallelograms look like a rectangle, but some of them look like a rhombus because these are types of parallelograms. And some parallelograms look like a square. So when you're going from top to bottom, when you're comparing them that way, it's some. Hopefully this chart helps you to kind of remember those true, false, never, always statements that can be really confusing. But if you can write down this chart and remember those arrows, that'll help. So I said that there were other charts, like if this one doesn't make sense, some people like to look at this one. So you've got quadrilaterals and then one pair of parallel sides are trapezoids and 2 pair of parallel sides are parallelograms. And then you've got rectangles are a type of parallelogram and rhombus are a type of parallelogram. And when you put both of those characteristics together, you get the squares. So this is the same idea in a different representation. Same with this big Venn diagram. So quadrilaterals are in the big square. And then there's 3 types of quadrilaterals. So parallelograms have 2 pairs of parallel sides. Trapezoids have 1 pair of parallel sides, and we haven't talked about kites today, but I know you did in elementary school. Kites have 0 pairs of parallel sides. So they're all in a different part of the big quadrilateral section. Notice parallelograms, 2 pairs of parallel sides, there's 3 types. Rectangles that have 4 90-degree angles, rhombus that have 4 equal sides, and squares that share both of those characteristics, so it's where they overlap. All 3 of these are types of parallelograms. So that's just another chart that you might like better to see the relationships between all of these quadrilaterals. If you have these notes, you can go ahead and fill these in with me. So parallelograms are 4-sided polygons. They have 2 pairs of parallel sides. Here's some examples over here. The opposite sides and angles are congruent, and the diagonals bisect each other, meaning that when they cross, they cut each other in half. The other half is exactly the same length as the other side. So, and diagonals are from one corner to the other. So from that corner to that corner and that corner to that corner, they bisect each other. Rectangles, 4-sided polygons, 2 pairs of parallel sides, and opposite sides and angles are congruent to each other. They have 4 90-degree angles, and their diagonals bisect each other again. Rhombus, 4 equal sides. So this is a 4-sided polygon with 2 pairs of parallel sides again. Opposite sides and angles are still congruent. This one has 4 congruent or equal sides, and the diagonals bisect at 90-degree angles. The diagonals, the 2 things that cut through the middle, like opposite vertex. All right, 2 more. Squares are 4-sided polygons. They have 2 pairs of parallel sides. Their opposite sides and angles are congruent, and they have 4 90-degree angles. Squares are the special one. They have all these characteristics, 4 equal sides, and diagonals bisect at 90-degree angles. Trapezoids are 4-sided polygons, but they only have 1 pair of parallel sides. They can also have 0 right angles, like this one doesn't have any right angles, or they can have 2 right angles, like this trapezoid. This one has 2 right angles right here. This is also called an isosceles trapezoid because the 2 sides that are not parallel to each other are congruent, like in a isosceles triangle. Go ahead and try some of these always, sometimes, or never sentences and see if you can get these right before I put the answer up. So use your chart with the arrows. A rectangle is always, sometimes, or never a quadrilateral. So a rectangle, we're starting down and we're going up on that chart, and that is always when you're going up. A rectangle is always a quadrilateral. 2, a trapezoid is blank isosceles. Sometimes it's isosceles, sometimes it's not, just like that 290-degree angle one. A quadrilateral is, so we're starting at the top and we're going down, which makes it a sometimes. Sometimes it's a rhombus. A square is, so bottom, up, always. Bottom, up. The square is at the bottom of that chart and it goes, it's always a type of a rectangle. A trapezoid is blank a parallelogram. Nope, that one goes side to side. That one's a never. And a rhombus is blank a quadrilateral. So we're going up on that chart. We're starting down and going up. That's always. A rhombus is always a quadrilateral. It will always have 4 sides, 4-sided polygon. A trapezoid is blank a rectangle. Nope, never. We can't move from side to side on that chart. All right, guys, hopefully this helps. Let me know if you have any questions. Thanks.